Welcome back, everyone. In our next session, we will take a look at access control policy. Access control policy is going to act as the main source of policy information on every single firepower platform, including firepower threat defense. This policy is going to generally control how the communication is going to be handled by the different firepower threat defense engines. And this way, whether communication is going to be blocked, allowed, or maybe inspected. So this policy is acting as a master configuration for all other policies. You can think of it as a main control room where you specify what individual engines of FTD you want to enable or disable. Some examples include SSL, identity, intrusion detection, authentication, and more. Pretty much every single policy that can potentially block a packet is going to be at some point activated, will be controlled through the access control policy. Okay, our ACP is going to generally consist of two sections. We've got mandatory or default rules that we can add. We take a look at on our device. I'm going to go to policies and then access control. We will take a look at this default access control policy, or maybe no, I'm gonna say we will build a custom policy. And this is what I will be using at the end of this session to test traffic control. So we will have to select, or we at least can select, one of the other policies as a base. And I'm gonna discuss this concept in just a second. I'm gonna give it a name. I will say that this is FTD-ACP. Okay, this policy is going to be assigned to our firepower threat defense sensor, and the default policy action is going to be set to block all. I'm going to save. I want to override the current policy. We will just have to deploy this change. No roles as of right now. But as you can see from this portion, we have two sections inside of this policy: the mandatory and default. Okay, and now these two sections will in reality only come into play when you are using hierarchical policies. So what I just showed you as I was building this policy, I was given a chance to select a so-called base policy for this policy, which concept is going to be useful when your network is supposed to be using more than one policy. And instead of tuning every single policy one by one, you want to come up with a base template that you will then kind of like clone for all individual child policies you want to use on different sensors or at different places in your network. And now these two sections, mandatory or default, will only come into play if you plan to use those hierarchical policies. Because if you have just one policy, it doesn't really matter which of those you will use. You can even create your own categories, your own sections. The roles will be always processed in a top-down fashion, like with an access list. So nothing changes here. But if you actually plan to use these, so you'll first build a base policy and then you will add a child policy, these sections will be important because your base policy, mandatory rules, you will have mandatory and default rules. Those rules will be added on top of the child policy that uses this policy as a template. So those rules will be put over here into the first portion of the policy. Then it's going to be mandatory rules of the child policy, what is going to follow. Next is going to be the default rules of the child policy, and the policy will be finally finished. It will end with the default rules of the base policy. So as you can see, the mandatory rules of the base policy, they will always take precedence over everything else in the child policy, just based on the fact that they are put on top of it. And as in any other case, the processing is still following this direction from the top to the bottom. But if you plan to use just one policy, which is what I'm going to be using in this and also other sessions, where you place those roles is not really important as long as you remember about the processing order. Okay, we will now take a look at all access control policy actions. I want to tell you what those actions do and how are they going to affect communication. So same as with pretty much any other policy, our access control policy rules, they will be build of conditions. And then at some point, we will also have an option. When I say add, let's add a role. Just to show you those. You will be able to select those actions from here. You choose an action, you enable or maybe disable the role. You select the section where you want to put it in, and then you have those different conditions you can choose from. Like zones, like IP addresses, VLAN numbers, if this is going to be layer 2, application inspection, ports, and stuff like that. Okay, so going back to those actions, the monitor action, this is what is not going to be affecting communication in any way. It's not something that is going to cause the packet to be dropped or allowed. This one is used just to log the flows. So if your role is configured with the monitor action and packet hits the role, it means that you will log this communication, but you will still evaluate other roles in the policy. So this is the only exception to the general processing mechanism of FTD, which says that when I have a match in my policy, I'm going to stop the evaluation. The monitor action is not a so-called final action. Maybe some of you are familiar with WSA. The WSA uses a concept of intermediary. And final actions. So the monitor action is going to be deemed as intermediary because it doesn't stop the other engines from evaluating the packet. Versus when you use any other action where all of them are deemed to be final, it means that the evaluation is going to stop once the packet matches a role configured with such as action. Okay, what is going to be the purpose of the block action potentially with the reset option? Block says that we want to drop communication without further processing. So it is going to be definitely a final action, as all other actions that we will take a look at in this session. We have that additional setting which allows us to reset a connection. So for TCP, this is going to mean that we will send a reset segment. Versus for UDP communication, FTD is going to try to send ICMP unreachable packet to tell the application that communication is broken. So reset is supposed to work for both TCP and UDP. Now, interactive block with an optional reset option is somewhat similar. The one difference is that this one is only going to work for web sessions. And what is going to be different from the block action is that at this time we will allow our user to choose whether we want to proceed with the session or do we want to keep the traffic to be blocked. Okay, what I'm trying to say here is that the user is going to be presented with a warning page. So this is where you will tell the user that it might be potentially dangerous to visit a given website, and it's going to be up to the user whether he wants to proceed or not. If he says, I want to accept the risk, the session is going to be further processed like with the allow action, and I'm going to explain what allow means in just a minute, versus if the user does not accept, the session is going to be processed as a regular block. So we will drop the communication and not involve any other engines for this session. As I just said, our next action is to allow, which is somewhat misleading name, at least in my opinion, for this action, because in reality what allow does is that it allows to inspect communication with other engines that might be potentially configured in a given role. Okay, so access control policy itself, it is able to enforce this pass or block behavior in general based on those layer 3 and 4 accessless rules. But you still have other engines like IPS, like file or advanced malware protection. You still have other policies like network discovery, like QoS, like identity, what gets activated by your rule. So when you say allow and other engines are enabled, it means that you are initially okay with the packet. It's like you tentatively say you want to pass it, but in reality you hand it over to other engines to take the final decision, make the final decision. So even when you say allow in the policy and your file policy says I'm okay with the packet, your QoS does not really limit the packet, but Snore, just IPS, says I want to block it, the end result is going to be that the packet is still going to be blocked. And this is why, in my opinion, my personal opinion, this action should be actually called inspect. Okay, we also have the trust action, which is how you will bypass a deep packet inspection and network discovery policy. So this is more of like a fast path type of processing for a packet, where you will want to pass the packet without involving those CPU taxing engines, but there is still going to be just a few engines what will inspect the traffic. Okay, so this is generally used to bypass the deep packet inspection, where deep packet inspection refers to IPS and file/advanced malware protection policies, collectively known as file policies. So IPS plus file policies, this is what we call a DPI. And when you say trust, it means that you will not be using those engines on the flow. You will still not use network discovery policy, but you will do instead is that you will potentially inspect the packet with security intelligence, with an identity policy, how you can check and enforce authentication, and you will still do QoS. So there is still a potential that a packet is going to be eventually dropped, like when your QoS rate limits the flow, or maybe security intelligence says this is a bad IP address. Even when you say trust in the policy, there's still a potential that the flow is going to be blocked. And as a side note here, don't use this action, don't use trust for protocols that negotiate secondary channels, such as, for example, FTP or TFTP, because it is going to take few packets for the firepower engine to figure out what's going to be the port that was negotiated. And now with the trust action, since you will bypass those more important engines, you might not see all necessary packets to figure out the right port before you push down the session to the Lina engine. So for that type of protocols, recommendation is going to be to use allow. We also have a concept of the default action, which is going to apply to the flows, to the traffic that didn't match any of the customer specific rules. There are actually 4 types of default action that we can use. We can say network discovery only, which means that we want to evaluate the flow with network discovery policy, and that's it. We can allow the communication. We can block the traffic, which is what you will normally select if you plan to go for next generation firewall deployments. Or you can finally say do intrusion prevention, which is not necessarily to block. It means use a next generation IPS to determine whether we want to allow the packet or not. Now note that one small exception here is that you cannot actually do file policies for the default action when you set it to intrusion prevention. You can only do IPS and you can do network discovery, these two. As with any other type of a firewall appliance or maybe IPS appliance, it is going to be possible to log connections on FTD. Logging is technically not an action that you can associate with a role. It is just one of the additional settings that you can configure. And remember that by default, logging is going to be disabled on every single role that you create, including the default role, the default action role that already exists, with two exceptions. One exception is going to be when you build a role and configure it with the monitor action. In this case, logging is going to be automatically enabled because this is the purpose of the monitor action. We want to track and log the session. And the other exception is when one of your engines is going to detect a so-called security event. So in most cases, it means that your snort detected an attack. In this case, the session is also going to be automatically logged. But other than that, every single role you want to track, you want to see log messages for, you will have to explicitly enable them. Maybe let's take a look at this in our network. I'm going to say that we will want to ping from 2 to 4, so via FTD. But maybe before we do this, let's just take a look at the FTD CLI. I want to make sure that we have the right interface settings defined and that we can ping all connected devices. So can we get to router 2? Yes, we can. Can I get to router 4, which is on the outside? I can do this. And do I have the routes to the respective subnets? We see that I have a default route pointing to 4 via the outside. So just to make it clear, this is going to be my outside. And this is my inside. And then if we take a look at the other route, I also have a route to the loopback of 2 via physical address of router 2. So everything is fine. Now, if I were to ping from 2 to 4, 2 obviously also has the routes. Let's try to get to, maybe let's just say show IP route 4444. Show IP route default. If I were to ping to the loopback of 4, we take a look at the log messages on FTD. So we will go to analysis, connections, then events. We shouldn't see anything here because logging in the default role is disabled. Of course, we don't have connectivity, but note that we don't see a single log message showing us this. So if I wanted to fix this, I would go back to the access policy and I would modify the default action in our policy role. I will say edit. This is what's now deployed on our FTD. I'm going to say modify the default action. You see this small icon to the right here, it says logging. This is where I can tell it that I want to log. I can log to the event viewer, which is my local logging GUI. I can log to a syslog server, or I can send a CCNP trap. Now, as a side note here, note that logging can be actually enabled at 2 different places. I can either log at the beginning of the connection, or I can log at the end of a session. So why is this going to be important? In general, you want to log at the beginning or at the end to not overwhelm FTD. And now which action you want to choose is going to generally depend on what traffic you want to log. Like if you know that the traffic is going to be blocked, you want to log at the beginning. Because if you were to say that you want to log at the end, well, with block action configured, there's going to be no end of the connection because the session is going to be blocked in the first place. So it's not going to show you anything. Versus when you want to log sessions that you expect to be allowed, in this case, you can log at the end. So ideally choose one of these options, not both of them. In this case, I can log at the beginning. This is the default rule. I'm just gonna say accept or okay, save, and deploy this change. And with this in place, we should see some log messages when I then ping from 2 to 4. I'm gonna repeat, let's say 15 times. Now let's go back to the connection events. Let's just send a few more ping messages. It takes some time to deploy those policies. And now we finally see that the session is blocked. This is the IP address, the physical address of router 2, and this is the loopback of 4 echo requests. This communication is dropped. Okay, so important stuff. Don't forget to enable logging in the default role so we can see all communication, which is in fact getting dropped by the FTD. Before we take a look at some configuration examples, let me briefly discuss the interaction between the access control policy and the underlying Lina engine, because the ACP is actually deployed to both firepower and Lina roles. In case of our firepower system, it is going to be this path where you can see the actual access control policy roles being deployed. You can take a look at this on the CLI. I'm gonna say go to the Linux mode, and then I will say show me the file which is stored, and what is gonna be the path, SF detection engines. Okay, double tap to see the actual identifier of the folder identifier, I should say, and then it's gonna be the next generation firewall roles what I want to take a look at. Okay, this command cat, it says display me the content of this file. We see that the policy kind of like consists of two sections. We've got what is known as priority roles. This is what's technically known as pre-filtering, and we will talk about this stuff in a different session. And we have regular roles, which in our case is to block everything with the log action. So log was added once we made the change on the GUI. Okay, but in the same time, those roles, they are also pushed to the Lina, to the ASA engine. They are added to the special access list called CSM_FW_ACL_. Let's say exit, maybe system support diagnostic CLI. And let's just say show run access list. We should see this ACL. It's over here. It's actually the pretty much the same stuff. This is pre-filtering. Policy roles, they are always put on the top. And this is our deny IP any role with the log keyword added. Okay, so like I said, the Lina engine, it also stores pre-filtering roles. This is going to be important when we get to the pre-filtering policy. But one additional thing that I also want to point you to is that those roles, as we will see in some other sessions, most of them is going to use the advanced keyword. Okay, and when you say advanced permit, it doesn't necessarily mean that communication is going to be allowed. In general, when you see this advanced option, it means that we want to send the traffic to the other inspection engines to the firepower. So like when you say in your FMC that you want to, for example, perform application level block, you will see advanced permit. Okay, but this was just to show you more of like the internals that happen on the back end. And stuff like this is going to be important pretty much only when you get into some more advanced troubleshooting. We will now take a look at few configuration examples. Actually, I want to come up with a single policy. Since most of you guys already have some security background, you've been working with Checkpoint, Palo Alto, ASA, zone-based firewall policies. The concept obviously is going to be still the same with FTD. The goal, at least this is my opinion, is always going to be to know the different features of a given platform, to know the conditions you can use, and also know the behavior of the underlying inspection engines and of course the processing order. And this is exactly what I will try to focus in this series. And because of that, the example I'm going to show you now is going to be really straightforward. I'm going to say that we will want to allow ICMP communication from anyone to anyone in any direction, I should say. And I'm going to say that we will want to allow telnet packets, let's say from the inside to the outside. Just these two things. You will take a look at this in our policy, access control. Really simple conditions, but it's good to see how to do this if you never worked with Firepower threat defense before. Okay, I'm gonna say add a role. Which category I will choose doesn't really matter because we have just one policy. I'm gonna give it the name. I will say ICMP. Okay, the action I will say is gonna be allow. So we will still allow other inspection engines to potentially look at this flow. And then what I'm gonna do here is that I will leave the zones. I will leave the networks because this is gonna be from any to any. So if I don't put a condition here or here, it by default assumes anything, which is exactly what we want. We will only focus on this section, on the protocol. And ICMP is not actually here, which means that we will have to add a custom object for ICMP communication. I will say that this is just ICMP. I'm going to select the protocol, and this is going to be for all types and all codes. We will save. Okay, it says that it exists. Maybe let me put it uppercase. Okay, let's just add it with a different name. ICMP2. This is going to be all ICMP packets. So this is what I'm going to add as a destination. And we take a look at the role. It says from any zone to any destination, any IP addresses, VLANs, users, applications. We don't really care. We only care about the destination, protocol, port, which in our case is ICMP. Now, other inspection engines like policy, intrusion policy, file policies, this is all disabled for this role. And then the other role that we will add is going to be for telnet. But this time we will care about the direction. So this is going to be the source. And this is going to be the destination. I could also use networks, network addresses as a condition, but I will just do it with my zones. My interfaces were assigned to the zones. Inside goes to zone in, outside goes to zone out, which means that next we will only have to select the protocol, and it's going to be telnet. This is going to be the destination. Okay, no inspection. And we will, maybe let's also enable logging for these at the beginning of the connection. I'm going to call it telnet. And let me enable logging for this one. And we will then save. and deploy this policy. So it's not rocket science. If you know how to build, how to deal with firewall policies on any single other platform, you will be able to do this on FTD as well. Okay, time to test this configuration. Maybe let's first take a look at this access list. At some point, it is gonna show us those rules. As usually, we have to wait for this change to propagate. Now we finally see those rules. We've got ICMP, we've got a telnet. We can also take a look at this on the firepower engine. Expert, and let's say, take a look at the file once again. It says allow. This is protocol number 1, so it must be ICMP version 4 versus 6 is TCP as the protocol, 23 as the destination port. This is telnet. So all good. We can now go to router 2. We can ping. We now have connectivity. And I should be also able to telnet to 4. Versus when I go to 4 and say that I want to telnet to 2, this should be blocked. And we should be now able to verify this on the FTD as well. Analysis, connections, events. So I see a block for the traffic initiated by 4, and this is source, this is destination, 23 telnet. And I see 2 allows from 2 to the loopback of 4, echo request, and then telnet. So we see that in-out is allowed versus out-in is not according to our requirements.